Dear friends, welcome to this section of the subject Statistics for Business and Management. In this subject, the important topic is diagrammatical and graphic representation of data. This is followed by the introduction of the statistics. Second one is methods of collection of the data. Third one is classification and tabulation of data. I am happy to welcome you all once again for this session. My request is, if there is any comment, please post it. For that, any further improvement means that can be taken into account. And also, I request you to share this to all your friends so that they can also get benefit of it. This is an opportunity for you to learn without any strain and also without any cost. And please cooperate and particularly try to subscribe the channel. I'm not compelling, and I'm requesting you to subscribe. Okay. The presentation of data in diagram and graph is called diagrammatic and graphical representation. It helps even a layman to understand the character of the data. It also helps to find out the increase or decrease of values over a period of time without any strain. Then importance of diagram and graph. Diagram and graphs help the common people to understand the character of the data. People find it easy to get an idea from the diagram, a graph, than to read the whole information presented in the tables. It also has more memorizing effect than data presented in tabular form. It helps for easy comparison of data from one period to another. Then distinction between diagrams and graph. Diagrams are prepared in the form of bar, circle, rectangle, pictogram, etc. Whereas graphs are in the form of lines. Diagrams are more attractive than graph. It conveys the meaning very quickly than graph. Graphs are more suitable for the time series analysis and regression analysis, but diagrams are not much suitable for advanced statistical analysis. Next one is general rules for preparing diagram. First one is heading. The diagrams should have suitable heading. The heading should appropriately represent the content of the diagram. It should be in short form as far as possible. Second one is scale. The diagram should be properly represented with scale. For example, if income is represented in x-axis and expenses is represented in y-axis, the division of amount should be done properly in both axes. Third one is drawings. Diagram should be drawn in good colors, dotting, crossing, etc. It should attract the readers and convey correct meaning of them. Fourth one is index. If different colors, dots or markings are given in diagram, then index should be given for diagrams. It would properly convey the meaning of the colors, dots or markings. Fifth one is attractiveness. The diagram should attract the people who happen to go through it. Sixth one is accuracy. The diagram should be drawn with accurate measurement to give the correct meaning of the data. Seventh one is size. The size of the diagram should be an optimum one. If the size is neither too big nor too small, then it will not appeal the people. Then types of diagrams. There is one-dimensional diagram, two-dimensional diagram, three-dimensional diagram, and fourth one pictogram and cartograms. We are going to study next of all these things. Then one-dimensional diagram. One-dimensional diagram is otherwise called as bar diagrams. In a bar diagram, only the length is considered as an important factor.
and the width may be of any size. The important types of bar diagrams are as follows: simple bar diagram, subdivided bar diagram, multiple bar diagram, percentage bar diagram, deviation bar diagrams. Now let us see about the simple bar diagram. It represents only one variable, but diagram can either be prepared on vertical or horizontal position. The most common type of bar diagram is vertical type. The figures like height, weight, students, sales and production in factories for various periods can be represented in bar diagram. Here one illustration has been given to prepare the bar diagram. Year for 2009 to 14 has been given. Sales are also been given. On the basis of data given above, the bar diagram is presented and shown here. And second one is subdivided bar diagram. Subdivided bar diagram is one in which each bar is subdivided into two or more parts. Each part may explain different characteristics of the phenomenon. For example, the bar diagram explaining the sales for a company can further be subdivided according to region-wise sales. An illustration for preparing the subdivided bar diagram has been given. Here region-wise sales have been given, divided into north, south, west, east. Total is also given. So 4 different subdivision, and in the bar, each bar is represented with that that regions. That with the different colors it has been mentioned. It is well represented in this page. Then multiple bar diagram. In a multiple bar diagram, two or more interrelated data are represented. Each year is associated with two or more bars to represent the interrelated data. The bars should be differentiated with colors or shades in order to identify the interrelated data. To explain it, an illustration has been given, that is year and production of different products A, B, C for different years have been given. That is well represented. In 2010, 3 bars are there, and each bar representing a particular product. A, one is A, another one is B, and another one is C. Then percentage bar diagram. The length of all the bars is equal in percentage bar diagram. Each bar is subdivided into different segments to explain the characters of the data. To explain it further, one illustration has been given. In that, years have been given for I think 4 years. Direct cost, indirect cost, profit, sales have been given. Then it should be converted into percentage. That is the total to be taken, and then it would be converted accordingly. And here, for example, 2012, the sales should be taken as 100, and that means for 70 it was 34. That calculation is 34 by 70 into 100. That means 49. Like that, 23 divided by 70 into 100. Then it would be 32. Like that, all calculations should be done so that the total should equal to 100. Here the percentage bar diagram is well prepared, and the diagram shows that different bars for different years, 4 bars have been given, and with the equal strength representing the percentage, character is percentage. Let us see the first one, 2012, the profit margin is represented in gray, and say the gray is very small when in 2012 when compared to 2015. One can identify that in the 2012 that direct cost seems to be high. The proportional direct cost seems to be high. Here we have to take into account the proportion of that total sales. That means sales have been different value, but it was converted for 100. Thereby, in that 100, how much portion is represented with different categories. Then next, deviation bar diagram. Deviation bar diagram represents data related to both positive and negative values. For example, data related to imports and exports and profit or loss of a company can be represented in deviation bar diagram. To explain it, one illustration have been given. Sales and profit for different years have been taken into consideration. As we have seen in the deviation bar diagram, that there may be chance of negative value also. Negative value means that will be going beyond below of the x-axis. X-axis represented with the 0 point, and any minus value that would be coming down of that. Here in this example, sales and profit has been taken into account, and sales in the period there may be possibility of getting sales or loss. In some situation that may happen. See, the in 2012 profit, thereby it's going up. Then in the second year also there is loss. Then it is represented in the below the x-axis. Also in 2014 profit, 15 loss. Then two-dimensional diagrams. In one-dimensional diagram, only length of bar is taken into account. But in two-dimensional diagrams, both length and width of bars are taken into account. The important types of two-dimensional diagram are rectangle, squares, circles, and pie diagram. Rectangles. This method consider both length and width of bar in the diagram. If the data related to one period or one company is comparatively higher or lower, the width of the bars should be adjusted accordingly. So width has some meaning in some kind of diagram. In some kind of diagram, the width is not taken into consideration. It won't, the character won't come for that category from that phenomenon. Then to illustrate, one example has been given. That here for product A and product B, direct cost, indirect cost, profit, a number of units sold, price per unit have been given, and on that basis the rectangle bar diagram should be prepared. Rectangle diagram has been prepared by preparing a table representing the product A for 25 units, product B for 50 units. That does not have any sense because illustration is also having that kind of information, and there is no calculations for this type of this table has no calculations when compared to the illustration given. Then rectangle diagram is represented in the total cost of product A and per unit cost of product A. Then total cost of product B, per unit cost of product B, and this is 25. Total cost divided by 25 giving per unit for A, and total cost divided by 50 gives per unit cost for the product B. The total cost is well represented and divided according to the profit element, indirect cost and direct cost. The next one is squares. In this method, each bar diagram is represented in the form of squares. Hence, square root of each value should be calculated to prepare the bar diagram. To explain it, problem with year and sales for different years have been given. here based on the illustration, for all the values square root should be taken. So that is sales 30,000 and square root of 30,000 should be taken, that is 173. That means one side would be 173. So all sides should be 173. It means like that all calculation to be done by taking the square root of it. And then it is represented here. Then you can find out that each will be given in the form of square, and it highlights what are the importance for different years. See, in 2011 very small square, and 2015 large square, big square. That means the concern is increasing year by year. So you find that lot of change when compared to 2011 and 2015. Next one is circles. Circle is a kind of two-dimensional diagram. It can be drawn by calculating radius for each given value. The radius is square root of the value, that is variable, divided by pi, that is 22 by 7. Square root should be divided by the pi, that is 22 by 7. To explain it well, one illustration has been given for different years and profit for those years. As explained by me, that the calculation have been done. First, the value 10,000 divided by pi. Pi means 22 by 7. That means say 10,000 into 7 divided by 7. Sorry, 10,000 by 22 into 7. That equal to 3,181.82. Then square root of that value should be considered. In the next one, 15,000 into 7 by 22 equal to 4,772.73, and square root of that value is 69.08. Like that all calculations should be done, and based on that circles have been calculated and presented. You see that the circle we can find out the importance, whether it is high or low, is based on the size of the circle. The size of the circle is low, it means in that year the profit is very low. Next one is pie diagram. Pie diagram is a diagram which represents data related to different characters in one circle. For example, the selling price of a product can be divided into various segments like factory cost, administrative cost, selling cost, and profit. Each segment should be converted into percentage form in order to represent in the pie diagram. After converting into percentage form, each percentage outlay must be multiplied by 3.6, since a pie diagram contains 360 degree. The values so obtained should be plotted in a graph to get a pie diagram. To explain it well, a good illustration have been given representing prime cost, factory cost, administrative cost, selling and distribution overhead, and profit with a different percentage. Then you are calculating the total, it should be 100. Then preparation of the pie diagram, some calculation to be done as mentioned earlier, that percentage is given and angles multiplied by 3.6, the value should be 126. Thereby the total seems to be 360. Here the total percentage is 100. The important one is to be multiplied by 3.6. Then it would be plotted like that. Each one will be with the different colors. Prime cost is one with one color, and from that we can find out which one is greater. It is easy to get an idea than it is in the table.
Next, three-dimensional diagrams. In three-dimensional diagrams, Length, breadth and width are the three important things which are to be taken into consideration. Three-dimensional diagrams are prepared in the form of cubes, spheres, cylinders, etc. Fourth one, pictogram and cartogram. Pictogram. First one, presentation of diagrams in the form of picture is called pictogram. It conveys more meaning than any other diagrams, especially for a layman. Under this pictogram, data are represented in the form of appropriate pictures that are most suitable for the data. Here an illustration is given to prepare the pictogram. Here animals, elephants, camels, deers, monkeys, giraffes, lions, bears in two different forests are given. Solution for the above illustration for drawing pictogram has been given. Here in the picture it has been well represented. By seeing the picture that one is attracted to look into that and study how many numbers are there in different forests. Next one is cartogram. Presentation of data in a geographical basis is called cartogram. It is otherwise called as statistical maps. The quantities on the map may be shown through shades, dots or colors, etc. The example for a cartogram representing the railway network map of India is presented here, Indian Railway Network. Next section is graphical presentation. That is, this chapter is diagrammatic and graphical representation. Now, graphical presentation is classified into two major heads. They are graphs of frequency distribution and a graph of time series. Frequency distribution related to discrete and continuous series can be well drawn in a graph. There are various methods for drawing graphs for frequency distribution. The most common methods are histogram, frequency polygon, frequency curve, ogives of or cumulative frequency. First one is histogram. Histogram is the most popular and widely used method of graphical representation of data. Histogram is a set of vertical bars. Vertical bars should be drawn in the graph. In histogram, the x-axis should be represented with variables and y-axis should be represented with corresponding frequencies for the variables. The frequencies corresponding to the variables should be plotted in the graph to get bar diagram. Then curve should be drawn through the midpoints of the top of all the bars. Then distinction between histogram and bar diagram. Histogram is different from bar diagram. Bar diagram will be represented with only bars, but histogram contains both bars and graph on the top of bars. Now the steps for the construction of histogram. Histograms are of two types. One, histogram for frequency distributions having equal class intervals, and histogram for frequency distribution having unequal class intervals. Equal class intervals may be example 0 to 10, 10 to 20, 20 to 30, 30 to 40, like that. For the unequal class interval means 0 to 10, 10 to 40, 40 to 50, like that. First one is histogram for frequency distribution having equal class intervals. Steps in the graph, x-axis should be conveniently divided to represent the variables. Y-axis should be represented with frequencies. plot 2 points each for all classes corresponding to the frequencies. These 2 points with equal distance is taken for the lower and upper limit of each class intervals. Join all the plotted points towards the x-axis to get rectangular adjacent bars. In order to get a clear idea, an illustration is given to draw the histogram for the equal interval classes. So marks classified into 40, 50, 50 to 60, 60 to 70, 70 to 80, like that. That means all are equal with equal class interval. That is 10 difference. For the first 50 minus 40 means 10, 60 minus 50 equal to 10, like that. So number of students are also represented. Based on that, the histogram has been drawn. Then you can find out that in the x-axis that bars are with the equal distance. All bars are with equal distance. Now histogram for frequency distribution having unequal class intervals. Following are the important steps for the construction of histogram when the class intervals are unequal. First one, the unequal class intervals must be corrected first of all through relative frequency density method. That is correlation of unequal class intervals equal to frequency of unequal class interval by width of the unequal class interval into width of the lowest class interval. Second one is in the graph, x-axis should be represented with variables. Third one, y-axis should be represented with frequencies. Fourth one, plot 2 points each for all class intervals corresponding to the frequencies. These 2 points with equal distance is taken for the lower and upper limits of each class intervals. Then join all the plotted points towards the x-axis to get the rectangular adjacent bars. Here an illustration is given to explain the histogram for unequal class intervals. Then you can find daily wages 0 to 10, 10 to 20, 20 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50, 50 to 60, 60 to 70. It's unequal class intervals. First 0 to 10. Then in that one case 30 to 35, like that. The solution for the histogram of unequal class intervals have been given, and one third column is a new, and the first one and second one is as given in the illustration. Then third one is frequency density. The frequency density is calculated like this. For example, 0 to 10 is calculated as 5 by 10 into 6 equal to 3. And for 50 to 60 is 5 by 10 into 6 into 32. Like that, all calculations should be calculated. Based on the above calculation, the histogram is drawn out. And here you find in the x-axis, the bars are of different distance. First one is 0 to 10. And you find that 10 to 20 are equal, 20 to 30 equal. Then 30 to 40, somewhat the difference is there, divided. Like that, 50 and 60 is big one, 60 to 70 is big one. Next one is frequency polygon. Frequency polygon is an improved method of histogram. It gives a curve instead of bars. There are two methods of construction of frequency polygon. First of all, the histogram should be drawn from the given data by taking variables on x-axis and the frequencies on y-axis. Then mark midpoints of upper side of each bar of the histogram. After that, join all the marked points to get the frequency polygon curve. Second one is, in the second method, First of all, plot the frequencies corresponding to midpoints of various class intervals. Then join all the plotted points to get the frequency polygon curve. To explain the first one method, illustration 13 has been given, that is represent the following data in histogram and frequency polygon, that is first method. Marks and number of students. Solve the equal with the all equal intervals only. On the basis of the above problem, given problem, the bar diagram should be prepared first, and the central point of all the top of the bars should be identified, and the curve should be drawn. Third one is frequency curve. Frequency polygon will not give a smooth frequency curve. It consists of sharp turns, ups and downs. Hence, the curve should be smooth with free hand, without sharp turns of ups and downs. First of all, a frequency polygon should be drawn by joining the plotted points derived from a frequencies corresponding to the midpoints of each class intervals. Then the frequency polygon should be smooth. There is no need to draw histogram to draw a smooth frequency curve. To explain that frequency curve, an illustration has been given, marks starting from 0 to 10 up to 80 to 90. Number of students have been given. Here normally, this is first one is variable, second one is frequency. Based on the above problem, the frequency curve is drawn. The frequency curves is 0 to 10 with frequency 4, variable 0 to 10, frequency 4. The midpoint to be taken, that is 5. Corresponding to the 5, and in the y-axis 4 should be identified. Like that, in the second category, 10 to 20, 10 to 20, the frequency should be identified in the mid value, that is between 10 and 20, that is 15. A dot has been given. In the 15, corresponding to that vertical, and then it is that frequency should be identified and mark should be done. So like that, all the dot points only will be available. There is no need for histogram. All dotted points should be joined together, means then it will give the smooth frequency curve. Next one is fourth one, ogives or cumulative frequency curve. Ogives are drawn on the basis of cumulative frequencies of various class intervals. First of all, cumulative frequencies should be calculated for all the class intervals. In the x-axis, class intervals should be represented, and in the y-axis, cumulative frequency should be represented. Plot points corresponding to the cumulative frequencies represent each class intervals. Then join all the plotted line to get ogives. It can be constructed through two methods. One is less than method, second one is more than method. First one, less than method. Under this method, cumulative frequencies from below are plotted against the upper class interval limits. Ogives under less than method gives a positive curve. Next, more than method. Under this method, cumulative frequencies from above are plotted against the corresponding lower class limits. Ogives under this method gives a negative curve. To explain the concept, illustration 15 is given, that is draw the less than and more than ogives from the following data. Marks have been given and number of students have been given represented on the second column. And here that cumulative calculation for less than ogive means From the starting point, as it has been given in the problem, take the marks and number of students from the first and second column. Then calculate the cumulative frequencies. First write 7, no problem. Then number of students in the 20 means 3. Add 3 and 7, you will get 10. Then next one is add 10 corresponding to 10, that is 20. Then add 15 corresponding just before that 20, that is 35. Then 24 plus 35, 59. 20 plus 59, 79. 10 plus 79, 89. 7 plus 89, 96. 9 plus 96, 100. Then based on the above illustration, more than due to be calculated, how it is to be calculated is shown here. That means that here one difference is cumulative frequencies start from the first row, 100, 93, 90, 80, 65, 41, 21, 11, 4, etc. In the previous case, you see that it is different. From 4, 11, like that it will start. On the basis of the illustration 15, the OGs, more than OGs and less than OGs have been calculated. And more than OGs start in upper trend and less than OG started from the negative one, from 100 to 9, 100 to 9 it has been coming down, and another one is going up. Graphs of time series. Time series is concerned with the representation of data for different periods of time. If these data are represented graphically, it may convey more meaning. It also helps for easy comparison of the changes of variable at different periods of time. X-axis of the graph for time series should represent various periods, year or month. Y-axis should be denoted with variables. There are two methods for constructing graphs for time series. They are nature scale method and ratio scale method. First one is nature scale method. In nature scale method, time series graph can be drawn on the basis of line graph. They are of two types: line graph or line chart for one variable, line graph or line chart for two or more variables. Then third one is band graph. Now let us study the line chart for one variable. Time series for one variable gives one variable for later periods. In time chart for one variable, x-axis should be represented with time and y-axis with variables. The variables corresponding to different periods should be plotted on the graph. Then the plotted points should be joined together to get the line charts. To know well of it, illustration 16 has been given, that is year and sales for starting from 2008 to 2014 have been given. On the basis of the illustration 16, the line chart has been prepared 2008 up to 2014. From 2014 x-axis, and the value can be identified on the y-axis, and dot mark should be put for all the years, and then the line should be drawn by joining all the dots. Then line chart for two or more variables. When two or more variables are available corresponding to various periods of time, line graph will show two or more line charts. X-axis should be represented with time and y-axis should be represented with value of variables. First of all, one variable corresponding to the year should be plotted on graph. Then the plotted point should be joined to get the line graph. The same procedure should be repeated for other variables also to get more line graphs. That particularly for the time series charts, that will start only in x-axis. Time may be month, year, like that. In order to know the line graph for two or more variables, here that year starting from 2007 to 2014 have been given, and cost of production and sales have been given for all these years, and on that basis that line chart for more than two variables to be calculated, to be prepared. Like the illustration 16, one line has been prepared. Like that, here two lines should be prepared. First of all, we have to take into account any one, say cost of production. Then cost of production for the year 1, 2, 3, 4, 5, 6, 7. That should be, identified. First means identified in the corresponding value in y-axis. That y-axis representing that value in amount. And cost of production thousands have been given for various periods. Dot should be put and all dots should be joined, and that will be giving the cost of production line that is taking an upper trend when compared to the first year to seventh year just like in the illustration. Then like that sales also to be plotted corresponding to the x-axis value that year to the y-axis variables plotted, and all the lines should be joined. Here there will be 7 dot points for each line to be joined. Quite naturally, sales would be greater than cost of production if there want to be profits. From this graph, you can find out that in the year 5 and 6 there is much different. That means the profit is greater, and in 7 gradually coming down. In fourth year, you find that the sales profit is much low because that two lines difference is very low. That is sales line and cost of production line. In 2000 and the second year, somewhat greater, profit is greater because the difference is greater. Next one is band graph. Band graph is a type of time line chart which shows the different components of variables in the graph. For example, the production and sales of a factory for different periods may be represented with different cost elements and profit. To give more explanation, illustration has been given for 2008 to 2014. That is factory cost, administration cost, selling and distribution cost have been given. Then profit is given. Then total means that sales. Here that total last column is sales, and when we are taking all that factory cost, administration cost, selling costs, total will be cost of production. Then cost of production plus profit is sales. In the band chart, just like line chart only, in illustration 1 we find, illustration 15 we find only one line. Like that we have to identify that each and every variable separately, and line should be drawn by putting the dot points corresponding to the value, corresponding to the cost y-axis value. X-axis showing time value, time and y-axis means that is cost. That here you find the factory cost at the coming last. Factory cost line would be starting from the first the blue color is given. That means upper of the blue color would be the line. and the coloring has been done below that. Like that, then advertisement cost is in, somewhat pink color, and that line should be upper of that pink. And then after marking that putting point, joining the line, and put color from the top to the up to the green color. Then selling and distribution cost to be drawn. That would be in the gray color. Gray color means upper of the gray color would be the dotted points joined. Then coloring should be done through the till the orange color. Then after that, profit. Profit would be a drawn line should be drawn like that from that 2009 to 2014, and it would be joint, and coloring should be done. Then total would be calculated. Total means sales. Then sales point, last point, and coloring should be done. Thereby, one can easily identify what are the total cost and what is the profit, what is the selling and distribution cost, what is the advertisement cost, and what is the factory cost. Next one is ratio scale. The graphs drawn with ratio scale are called ratio charts or logarithmic charts. Ratio scale shows the relative change in variables, whereas the natural scale shows only the actual change in variables. In order to compare the relative change of variables over a period of time, logarithmic chart or ratio chart is prepared. In the ratio chart, the x-axis represents the values in natural scale. It represents year or month. Y-axis represents the logarithm of the values of variables. Logarithmic chart is also called semi-logarithmic chart, since the vertical scales are logarithmic and horizontal scale shows the variables in absolute values. To give more explanation and illustration have been given, that is year and units of production have been given, and from starting from 2008 to 2014, units of production have been given on that basis. On the basis of illustration 19, that logarithm value has been calculated for all the years. Limits of production is given. The first two columns are as from like the illustration. Third one is calculation based on the that is calculation is logarithmic value. Log of 700 should be calculated. That means quite naturally some 3 digits means 2. And next one is 4 digit means 3. Thereby 2 point something, 3 point something, that one can identify it from the calculate. Like that you have to take all the values. Chart is prepared only based on the logarithm value. Logarithm value should be taken into consideration for plotting the points. Say 2008, the logarithm value is 2 point something, they plotted, and in 2019, the logarithm value is 3 point something, there it was plotted. In logarithm 2010, it was 3.4 something like that, there it was plotted. In 2011, it was also 3 point some value it started. In 2012, it was also corresponding to 3.5, not reaching 4. In 2014, it reached almost 4. Like that, plotted. It would be plotted, and then line should be drawn through the plotted points.